Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, we have completed all theories. Now we will see examples. Okay, see, the angular speed of a motor V is increased from 1200 rpm to 1320 rpm in 16 seconds. Question A, what is its angular acceleration, assuming acceleration to be constant? And second, how many revolutions does the engine make before or during this time? First of all, understand data. See, the angular speed of motor wheel is increased from 1200 rpm to 1320 rpm. So see, here it is initial angular speed omega 0 is equal to 1200 rpm. rpm means revolution per minute. rpm means the revolution per minute. You have to convert this revolution per minute in radian per second. Okay, and we know that one revolution means starting from this point and I mean reaching to this point, one revolution means 2 pi radian. 2 pi radian. One revolution means angular displacement is 2 pi radian. Okay, so how to convert this rpm? It is 1200 into, first of all, revolution means 2 pi radian. Per minute means divided by this 60 seconds. Divided by a 60 seconds. Okay, so see, here it is 0. It is 0. Okay, it is now it is 6. So 6. Here it is into 2. So 20 into 2. It is 45 radian per second. So it is initial angular speed. Now similarly, I will find final angular speed. What is final angular speed? Final angular speed is denoted by omega, and it is 1320 rpm. So yes, again I have to convert rpm in radian per second. Again I have to convert rpm in radian per second. So how to convert this rpm, that is radian per second? And again I have to multiply by 2 pi by 60. So it is 1320 into 2 pi by 60 radian per second. Now 1320 into 2 divided by 60. So it is 44. Okay, again 1320 into 2 is equal to divided by 60 is equal to, it is 44. So it is 44 radian per second. Yes, it is 44 radian per second. Yes, pi you have to include. So omega is equal to, it is 44 pi radian per second. Okay, so two data: initial angular velocity, final angular velocity in 16 seconds. So time t is equal to, it is 16 seconds. Now question A, what is question A? See, what is its angular acceleration? Angular acceleration means alpha. Angular acceleration alpha is equal to what? So see, if you observe data omega 0, omega t and alpha. So yes, you have to use this equation. That is alpha is equal to omega minus omega 0 upon t. What is omega? 44 pi. What is omega 0? 40 pi divided by what is time? It is 16. Yes, it is 16. Clear about this? Clear about this? So alpha is equal to this omega minus omega 0 upon t. Upon t. Clear? Okay. So is equal to 44t minus 40t. So it is 4 pi divided by 16. It is 4 pi divided by 16. Yes, you are given time, that is 60. Okay, so yes, is equal to, it is 4, so it is pi by 4 radian per second square. Alpha is equal to, it is pi by 4 radian per second square. Simple. Okay, so yes, alpha is equal to, it is pi by 4 radian per second square is your answer. Now, how to find second question? Now, how to find second question? Okay, see how to find second question. It is how many revolutions does engine make during this time? How to find revolution? To find numbers of revolution, first of all you have to find angular displacement. So first of all find angular displacement, that is theta. You find angular displacement. Find angular displacement, that is theta. And how to find that angular displacement theta? See, we have one equation, that is theta is equal to, it is omega 0 t plus half alpha t square. Yes, omega 0 t plus half alpha t square. Yes or no? Yes, it is. So with the help of this equation, first of all find theta, that is theta is equal to omega 0. What is omega 0? Omega 0, yes, it is 14 pi. So it is 14 pi. What is t? It is 16. Okay. Plus here it is half. Alpha, what is alpha? It is pi by 4. It is pi by 4. And t square means it is 16 square. T square means it is 16 square. Clear? Okay. Okay. So is equal to, it is equal to, it is 16 into 4. So it is 640 pi. It is 640 pi. Plus here it is 16 square means 64. 64 divided by 8, so it is obviously 16, sorry, it is 16 square, so it is 16 into 16 is equal to, it is 256. 256 divided by it is 8, so is equal to, it is 32. So is equal to, it is 32 pi. Is equal to, it is 32 pi. Clear about this? So is equal to, what is the addition? It is 645 plus 32. So it is 4 plus 3 is 7. So it is 672 pi radian. It is 672 pi radian. Clear about this? Okay. So yes, it is theta. Now how to make addition? See, for one revolution, angular displacement is 2 pi. So I can write reverse statement. If angular displacement is 2 pi radian, number of revolution is 1. Here angular displacement is this 672 pi. Then for that, what is number of revolution? So yes, number of revolution is equal to, it is 672 pi divided by, it is 2 pi. So pi cut 672 divided by, it is 2. So is equal to, it is 336. So is equal to, it is 336 revolution. It is 336 revolution. Clear about this? So yes, it is one question which is based on equations. Okay, first of all you have to find alpha, then you have to find what is angular displacement, and then you have to find what is numbers of revolutions. Okay. Now next question, see, find the torque of force 7I plus 3J minus 5K above the origin. Position vector of particle is I minus J plus K. So see, first of all identify data. Find the torque means you have to find torque is equal to question mark. Force, yes it is given. F is equal to 7I plus 3J minus 5K. Position vector R is equal to I minus J plus K. Now what is the equation of torque? You know, tau is equal to, it is R cross F. Now how to find cross product according to chapter number 4. See, here it is equal to, yes, first row I, J, K, second row, that is first vector means it is R means I caret minus J caret plus K caret. What is coefficient of I caret? 1. Coefficient of J caret? minus 1. Coefficient of K caret? 1. Okay, then what is F? Yes, F is equal to this coefficient of I7, 3, and here it is minus 1. Now you have to simplify this. How to simplify that? You already know. It is equal to, first of all, I cap in bracket minus 1 into minus 5. So it is 1 minus 3 into 1, it is 3, minus J, 1 into minus 5, minus 1. In between there is always minus sign. 1 into 7, that is 7, plus K caret 1 into 3, that is 3, minus 7 into minus 1, that is minus 7. So minus equal to plus 7. Okay, so is equal to, it is 5 minus 3, it is 2 I caret. Minus 5 minus 7 means minus 12. Minus minus will become plus, so it is plus 12. And 7 plus 3 is 10. So yes, it is plus 10 K caret. So yes, it is equation of torque. Simple. Okay, you have to remember equation of torque, that is R cross F, and how to find cross product. Okay, now next question. Now next question, see, a cord is wound around the ring of flywheel of mass 20 kg and radius 20 cm. A steady pull of 25 Newton is applied on the cord as shown in figure. And you have to find these respective questions. Compute angular acceleration of wheel, find work done by pull when 2 meter of the cord is unwound, kinetic energy of wheel at this point, wheel starts from rest, and compare answers of B and C. See what is question actually, understand. Okay, you are actually given one flywheel. Flywheel is nothing but a disc. Flywheel is nothing but one type of disc. Okay, flywheel is one type of disc. Its mass is given, see, its mass is capital M, that is 20 kg. Its radius is, that is, capital R is equal to 20 centimeter, means 0.2 meter. Okay, a steady pull of 25 Newton, F is equal to 25 Newton is applied on the cord. Now what is situation actually, see, if you have one disc like this, okay, and one cord, means one string is wound round like this. And if free end of that cord is pulled in downward direction, so obviously it will perform rotational motion. Simple. It will perform rotational motion. Yes, you know it. Yes, you know it. Okay. Okay. If you are given one disc which is wound with one string, and if you rotate or if you pull this string, then this disc will rotate. Will perform rotational motion in this direction like this, about this axis, axis which is passing from its center and perpendicular to its plane. Okay, so first thing here, if flywheel performs rotational motion, about an axis passing from its center, and normal to its plane, Okay, so it is first statement. So what is first of all moment of inertia? Because you will need, okay, moment of inertia. So what is moment of inertia about this plane? So moment of inertia I is equal to, so therefore moment of inertia I is equal to, equation is equation is mr square by 2. Yes, from table you can find this equation. Okay, moment of inertia for disk about its axis passing from its center and normal to its plane. So is equal to, what is value of mass? Mass is, it is actually 20. Radius is, it is 0.2 its square and divided by this 2. Yes, you have calculators, don't worry about it. 20 into 0.2 into 0.2 is equal to 0.8 divided by it is 2. So it is 0.4. Yes, it is equal to, it is 0.4 kg meter. So it is equation of moment of inertia. Okay. Now see here statement, flywheel performs rotational motion and rotational motion is due to obviously torque. Rotational motion, what is the reason object performs rotational motion is due to torque. So now I will find torque. Torque acting on flywheel. Torque acting on flywheel. Now what is equation of torque? Torque is equal to, it is force into perpendicular distance. So torque is equal to, see here it is this pull force is applied like this. From this axis, this distance is nothing but radius r. Yes or no? Yes, it is. And due to this pull in downward direction, this disk is performing rotational motion. Yes or no? About this axis. So yes, it is force, and this radius is nothing but perpendicular distance. Okay, so yes, how to find torque acting on flywheel? Torque acting on flywheel, force F, perpendicular distance means nothing but R. Okay, so tau is equal to 8. So what is the value of force? It is 25. Okay, and what is of radius? Yes, radius is 0.2. It is 0.2. So yes, 25 into 0.5, it is tau is equal to, it is 5 Newton. It is 5 Newton meter. Okay, so yes, it is value of torque tau. It is value of torque tau. Okay, now we will find our questions. Okay, first question. A. Compute angular acceleration. You have to find angular acceleration alpha. Angular acceleration. So angular acceleration alpha is equal to what? See, I tau alpha, there is a relation between that actually. Okay, tau is equal to, it is I alpha. So therefore alpha is equal to tau upon I. Tau is 5 and I is 0.4. So 5 divided by 0.4, 5 divided by 0.4. Yes, it is 12.5. So therefore alpha is equal to, it is 12.5 radian per second square. Okay, again 5 divided by 0.4. Yes, it is 12.5. Clear? So alpha is equal to, it is 12.5 radian per second square. So it is, yes, it is first question, that is alpha. Okay. Now what is question B? So what is question B? What is question B? See, question B is you have to find okay, what is work done by pull if 2 meter of the cord is unwound. What is work done by pull if 2 meter of the cord is unwound? Chalo. See, how to find. Okay, find work done means you have to find W. By the pull means F is equal to, it is 25 Newton. When 2 meter of cord is unwound, 2 meter of cord is unwound means 2 meter of string is unwound, it is going in downward direction. Okay, so D is equal to, it is 2 meter, distance is equal to 2 meter. So therefore W is equal to, we know equation of force, FD is 25 into 2, so it is 50. Clear? Okay. Next question. Kinetic energy of wheel at this point. Wheel starts from rest. Kinetic energy of wheel at this point. Kinetic energy means it is performing only rotational motion. Yes, disk is performing only rotational motion. Flywheel is performing only rotational motion. So rotational kinetic energy. Rotational kinetic energy. Rotational kinetic energy. This expression is K is equal to half I omega square. K is equal to, it is half I omega square. Okay. Okay. Yes, you have value of I, but what is omega at this point? At this point. So yes, you have to first of all find omega. Yes, first of all you have to find omega. Then how to find this omega? Omega at this point means when 2 meter of this cord is unwound. So first of all, for that 2 meter of cord unwound, we will find angular displacement. Now how to find angular displacement? See, we have one relation actually. Okay, K for distance equal to circumference 2 pi r. Yes, for distance equal to circumference. For distance equal to circumference, angular displacement is 2 pi radian. Is 2 pi radian. So what is distance here? D. So for distance D, or directly what is for distance 2 meter? So for distance 2 meter, what is angular displacement? So therefore theta is equal to, it is 2 into 2 pi divided by this 2 pi r. So 2 pi cut, 2 pi cut. So therefore theta is equal to, it is 2 divided by r. So it is 2 divided by 0. Yes, because yes. What is radius? Radius is 0.2. So what is angular displacement? It is 10. Is equal to, it is 10. You hear about this? Yes, theta is equal to, it is 10. Yes, theta is equal to, it is 10. Okay. Now you have to find omega. Then how to find omega? Again, you can use this equation: Q omega square minus omega 0 square is equal to 2 alpha theta. Because you are given the wheel starts from rest. Wheel starts from rest means omega 0 is equal to, it is 0. Okay. So omega square minus 0 2. What is the value of alpha? Alpha it is 12.5 whole square. So it is only 12.5. And what is theta? It is 10. So omega square is equal to, first of all we will find omega square. It is 2 into 12.5 into, here it is 10. So is equal to, it is 250. Is equal to, it is 250. And we will keep it as it is. Omega square is equal to 250. Because you have to find kinetic energy. So kinetic energy K is equal to half I omega square is equal to half. What is value of I? I, moment of inertia, is 0.4. So it is 0.4 into omega square is 250. So 250 into 0.4 is equal to, it is 100 divided by 2 is equal to, it is 50. So yes, this kinetic energy K is equal to, it is 50. This kinetic energy K is equal to, it is 50 joule. What is work done by pull? Work done by pull as it is 50 joule. Okay, so your last question is compare answers of B and C. What is question of answer B? C. Question B is find work done by pull when 2 meter of the cord is unwound. Work done. Okay, and due to that it will perform in rotational motion, so you will have kinetic energy. So work done on flywheel is equal to kinetic energy gained by flywheel. So in option D you have to write the work done on flywheel. Work done on flywheel is equal to energy gained by flywheel is equal to energy gained by simple. Okay, so yes, this question. It is question. Clear about this? So yes, it is one important question in which you have to find total 4 questions, A, B, C, D. Okay, and yes, it is easy question. Yes, it is easy question. It is based on equations. Clear about this? So yes, only 3 questions for today. Next question we will solve in next lecture. For today, this is it.